This is the second lesson of our module on matrices. So the objective of the lesson is to solve a system of linear equations using a matrix. And the why is that relating something new, matrices, to something familiar, solving systems of equations, creates connections in our brains that enable learning by relating one process to a parallel similar process. So to just start off by defining what a matrix is, we briefly mentioned this in the last lesson, but a formal definition is necessary. So a matrix is a rectangle of numbers arranged in horizontal rows and vertical columns. So notice that these numbers are all surrounded by these square brackets that makes it a matrix. We also label row 1 as R1 and row 2 as R2. We always start with our first row and then go down second, third, and so on. The plural of matrix is matrices. There are some additional facts that, as a person passionate about math, I feel is worth mentioning. We won't specifically need to use these facts, at least in these words, in this course, but I would feel insufficient if I didn't mention them. So we also number columns, C1, C2, and C3, so on. We don't really do much with column operations at this level of math, but in higher level college math courses, you might use columns instead of rows for certain things. We tend to call matrices by capital letters. So if capital A is a matrix, then lowercase a with the subscript ij is the entry, so the individual number, in the matrix in row I and column j. So in the example above, the 1, 2 entry is R because it's in the first row, the top, and the second column, right. So this would be 1, 1, 1, 2, 2, 1, 2, 2, and so on. So matrices are tools, and a lot of what we'll be doing is learning how we use these tools to accomplish specific tasks. In order to relate a system of equations to a matrix, we need to define the type of matrix that we're going to create. So a system of equations can be written as an augmented matrix. The word augment means to add something. So we're adding something onto a matrix. It will be clear what we're adding in a moment. So to make the augmented matrix, the variables coefficients form a matrix on the left. So in blue, the part that turns into the matrix is over here, specifically the coefficients, so the number in front of the variables. It's also really important that our variables are stacked on top of each other. So x's are all in one column, y's are all in another column, and so on. So the variables coefficients form a matrix on the left, and on the right, these constant terms, or the solutions, if you will, form a column on the right. We could also call this a matrix with 2 rows and 1 column. You might also, in future math classes, hear it called a column vector. Vector being numbers that have multiple properties, such as 2 elements stacked on top of each other. And we separate these two things with a line. And so if we were to write this augmented matrix, notice that we have our coefficients, 3, positive 2, positive 1, and negative 1. So those are the coefficients from our variable side. And then we have 7 and -1. The negative sign got a little bit obscured there, forming this column on the right. Notice that the entire matrix is still in these square brackets, and we have this vertical column between the coefficients of our variables and the portion that represents the constant terms. So the first example, and I'm going to use some color coding before I write things down. So we want to write an augmented matrix. So we're given 3 equations. We have 1x plus 1y minus 1z equals 5. Then we have 2x minus 3 plus z is equal to -8. And then we have 4x negative 2y minus 5y is equal to 3. So in order to write the augmented matrix, I need all of my brackets. And to make sure my spacing is correct, I'm going to just put the left bracket here. So when there isn't a coefficient written, it's implied to be 1. So we have 1, 1, -1 from our first equation. And that reminds me of one thing I wanted to do. I want to color code. So this first row is in green. The second row will be in blue. So our coefficients are 2, -3, +1. And then our row of coefficients in the third row is 4, -2, -5. Now we draw the line that augments our matrix. And I can draw the second bracket in now because I know how much space it's going to take to write one column of numbers. So we have 5, -8, and then +3. So this is our augmented matrix. Take a moment to pause the video and practice writing the augmented matrix for the system given here. When you unpause the video, in about 5 seconds real time, I will write the solution so you can check your work. Okay. So all in one color this time. I have my bracket. The coefficients from the first equation are 2, 3, -1. I'm going to leave a little extra space to draw the line in and write the 7. Then from the second equation, we have 3, -1, +2, a little bit of space, 19. Third equation is -1, +2, +3, and 10. And I draw in the second bracket and the dividing line, and this is the augmented matrix. Once you've done a few of these, it becomes incredibly automatic to write the augmented matrix. Our goal does not stop here. We want to use this matrix to actually solve the system of equations. So in the next video, we will continue this lesson discussing how we can achieve that goal.